Sometimes we are not interested in determining the present value of an annuity, as we have been doing so far. Rather, we are interested in determining the future value of an annuity. This would best be illustrated using an example. Let's suppose that you have decided to put away $2,000 in your investment account every year for the next 5 years, where you will make your first deposit of $2,000 1 year from today. So again, you've decided that you're going to put away $2,000 every year for the next 5 years, where you're going to start by making your first deposit 1 year from today. Right? So starting by the end of the year. So this is important, and I always encourage students to draw out a timeline. This always helps, especially if you are new to these ideas of annuities and present value and future values. This really helps. And so what you're saying here is this. You're going 5 years out on your timeline, and you're effectively saying that I'm going to start putting in $2,000 every year with the first deposit that I'm going to make by the end of the year, by the end of the first year. The next one is going to be by the end of the second year, and then one by the end of the third, another one by the end of the fourth, and finally the last one at the end of the fifth year. So 5 $2,000 deposits. Here, the question that you're interested in answering is, how much will I have, or how much will you have in your account by the end of these 5 years, by the end of the 5 years, if the annual interest rate is 3%. Previously, we've been interested in questions where we were, asking ourselves, what is the worth of an annuity like this today? So that was the question of present value, but we're not talking about that anymore. The moment we are interested in answering something like, how much will I have at the end of 5 years, we're going into the future. And so what we are interested in is how much these 2,000s are going to be worth in the future, right? So what is the future value? Now, if you wanted to approach this a little bit more generically, then you'd say, okay, let me start with this $2,000. I'm going to put this in the bank at the end of the first year. And if I were just interested in knowing how much this would be worth by the end of the 5 years, then this guy would grow by 3% in the first year, and then that amount would grow by another 3%, and then that amount would grow by another 3%, and then that would grow out by another 3%. So this would grow out 4 years, 4 times. So the future value of this 2,000 alone would be 2,000 into 1.03, where 3 is the interest rate, and you raise it to the power 4. And then you'd say, well, wait a minute, but that's not the only 2,000. I'm going to deposit this $2,000 as well. And this, as you can imagine, is only going to grow out for 3 years, right? So 1, 2, 3. So the future value of that at the same point in time, like 5 years, is 2,000 into 1.03 raised to the power 3. You can see where this is going, because the next 2,000 is going to grow out only 2 years. The next 2,000 is going to grow out just 1 year. And so if I just go to the very last one, the last one is just going to be 2,000 just by itself, because this is going to happen right at the end, and this guy is not going to grow. All right, so this is, if you could do all of this, great, you'd have the answer. Let's try and simplify this. 2,000 seems to be the common factor here. So if you take 2,000 out, you're basically left with 1.03 raised to the power 4 plus 1.03 raised to the power 3. And then you keep on going, and then the last one is this 2,000 by itself. So you basically need 1. Right? So again, if you do 2,000 times this one, you'll get this guy. It turns out that you can do a little bit of fancy math, which I'm not going to bore you with here, but it turns out that this entire expression, this entire thing, this solves out to 1.03, where this is 3 is the interest rate, raised to the power 5. what is this 5? This 5 is capturing the fact that it's a 5-year annuity. So this 5 is basically 5 years. Minus 1, all of this divided by 0.03, where again 3 is the interest rate. So basically this entire expression solves out to this, and so you still have this 2,000 over here. So you'll take this guy and multiply it, and if you do this math, it turns out that the answer solves out to about 10,618.27. So that is how much you are going to have by the end of 5 years if you deposit $2,000 every year for the next 5 years, starting with your first deposit 1 year from today. This is an important assumption. This formula only comes by if the first 2,000 is occurring 1 year from now. And so you can see that there's a pattern here. This is like 1 plus r, and so 1.03 is the 1 plus r, raised to the power 5, where 5 is the number of years, so that's t, minus 1 divided by, again, r is the interest rate, and 2,000 is your constant cash flow C. So the general formula for the future value of an annuity of C dollars, where you're going t years out into the future. In our example, this was 5. In our example, this C was 2,000. And so the general formula is this, where this R, again, in our case, was 3%. So you can use this formula to determine the future value of any annuity that is going t years out into the future.